From natural disasters to people working deep within mines, delayed communication is a real problem here on Earth, and it could be a problem for future space missions. Advanced analytical software could help in these type situations. Jeremy Frank is showing us how they're learning about autonomous operations through a drinking water investigation on the station.
TOCA stands for Total Organic Carbon Analyzer. This is a piece of hardware that's on board the International Space Station, and the crew uses it to make sure that their water is safe to drink. And so they have to sample their water supply about once a week, maybe twice a week, in order to make sure the water is all right to drink.
We all want good drinking water.
Yes, we do.
They don't get the spring bottles up there, right?
I don't think they do, no.
All right, so they have to test it, and then you have a way now that they can look and see what's happening to that water, right?
That's right. So today this is a job that's actually done by flight controllers at Johnson Space Center. So the flight controllers today are responsible for deciding when to test the water. They're the ones who decide how to look at the water samples after they're taken and go dig deep into it and make sure the water is safe to drink. They're looking at the health and safety of the TOCA hardware to make sure it's not malfunctioning. But on a future human exploration mission to a near-Earth asteroid or to Mars, that's a kind of job that maybe flight controllers on the ground can't do anymore because the crew and the vehicle will be so far away. So we've embarked on a project to help understand what percentage of that job that's done on the ground astronauts can do instead of the ground controllers. Some of the things that we do today we'll still be able to do tomorrow. Plans for a week in advance, plans for a month in advance, there's no need for the crew to do those things. But things that the crew's doing day by day, things that they have to call the ground and ask for help for, if it takes 1 minute, 2 minutes, 5 minutes for the ground to come back with an answer, those jobs are going to be very frustrating. In some cases, they won't even be possible. So an experiment like the one that we're doing is designed to help understand what the crew can do. Once we decide that something is possible, then you can decide whether it's essential. So what we did was developed a web application that helps the crew manage this Total Organic Carbon Analyzer and its activities on a daily or weekly basis. And so there are three main things that a crew person can do today to help manage this thing that today would be done by the ground. So what we'll do is we'll take a very quick look at what some of those functions are. So the first one is the crew can manage the plan. So what we have is a piece of software whose results are presented through the web browser. And what it does is it shows what's happening this week. In this case, we see that there's one activity that's finished. What we see for the next 2 weeks is that there are a grand total of 3 activities, and each one of these is recommended. So there's a piece of software that knows what the rules are for the water sampling. It knows what activities had been performed in the past, and what it does is computes which activities it thinks the crew is supposed to do in the next several weeks. So rather than have that information in a crew person's head, they can now look at the software and say, oh, the software thinks I'm supposed to do these things. The crew person can then say, I think those recommendations are right on, and I will send those schedule requests to ground. If they want to, they can add activities on their own because they think that those activities are necessary. So the software is not replacing ground. The software is not taking the responsibility away from the crew. It's helping the crew remember what the rules are and what they're supposed to do. Sometimes when you're driving your car or when you're listening to your dishwasher, you have a sense that something's not right. It's not that it's broken, it's not that it failed to turn on, but it sounds funny, or your car handles funny, or the water tastes a little funny. So those are not known problems, but they're differences, anomalies. And so what we have is a device historic comparison element that says, is the device performing in an anomalous way? It's not known to be faulty, but something's a little different, and maybe it's a sign that you should start paying attention, that you should watch what the device is doing in the near term. If there's a problem, and if the crew needs to respond to a problem, or even if the crew just needs to remember how a device works, what it does, what its function is, where that part is inside the device, there's a lot of information that we've packaged up in a variety of forms to make it easy for the crew to do that. So we have a variety of schematics, we have a variety of pictures, we have a variety of references that the crew can use to help them look up any piece of information so they don't have to ask the ground for help. It's just one more way that we can eliminate that light time delay that we might experience on one of those future missions. It's just one more thing that helps the crew be more autonomous.